excited as I am about the Spark optimization series. Well, this is the first video in the series, and I created the introduction video just to let you know what you can expect from the series and a very high level overview of Spark, its architecture, how it actually runs our code, how it generates the physical plan, and it's being executed on the Spark cluster. So if you want to just brush up your skills before starting this video, please do watch the first video. If not, then you are already in a good place. So we're gonna today talk about our very first problem, which is skew. So first thing first, what is skew, right? So in English vocabulary, skew means uneven. Okay, so uneven, and in data terms also, it somehow relates to the same meaning, which is uneven. In this case, the data is uneven. Okay, so let me just explain you what is a skew or what is a skew problem in Spark by taking a simple example. Okay, so you see this, it's a node, this box, it's a node or a machine, you can say, and then it got some partitions. Let's say it has 5 partitions, and then you have written a code to read something from somewhere. Let's say you are reading some data from a file system, for example. And now what happens? By default, Spark reads data in the chunks of 128 MB, right? So each partition would have 128 MBs of data. This is the default configuration, but of course you can change this, and you can change this configuration using max partition bytes. Sometimes it's very important to know the value of this parameter or the configuration, and it can really impact the performance. I'm not going to talk about max partition bytes in this video, but if you want to know more about max partition bytes or similar configurations in Spark which can actually directly affect the performance, please do let me know in the comments, and I can prepare a video on all the properties that might actually be good to keep a note on. But that being said, we read the data in the chunks of 128 MB, right? All good, no problem. And we are assuming the data is actually equally distributed, and this is also be the case in real life. Okay, now once you have the data in the partitions, you're gonna do some operations on the data, right? So you do it some transformations, which are of course gonna be in memory because Spark does all its work in memory, right? So let's say after some transformation, of course when you do the transformations, there's gonna be a shuffle operation, right? So we are talking about wide transformation here. Okay, so not the narrow ones, but just to give you an example, you did some transformation and then your partition now looks something like this. So you can actually already see that partition 5 is actually quite explicitly visible, right? Because it's very big, right? So now if the partition is big, which means it has more data, right, compared to the other partitions. So if the partition is big, then of course it's gonna take almost 2 times RAM, the memory, right, to hold this data. Also it's gonna take 2 times the time to perform the task, right? So let's say I give a same task to all the 5 partitions. So whatever time these partitions are taking to complete the task, it's gonna be double in the case of this partition, right? And not just this, there could be also problem of out of memory or the spill. Okay, so let's say you have a very big partition and then you are performing some operation on that partition and maybe you don't have enough memory. So what you're gonna get is the very common error that everyone gets, which is out of memory error, right? Because you have a very big partition and now you don't have enough memory to perform the task for the particular partition, right? So all these problems can arise when you have a skew partition. And as you may already assumed, this partition is called skew partition, right? So this partition is a skew partition because it's uneven. If you see all these partitions are even, this is uneven. So this partition is a skewed partition and it can bring so many problems, right? So that being said, now you have a skew partition. Now how to solve this? So one thing that you might think is straightforward, that hey look, you have a big partition, which means you have a big data in this partition. Okay, so you might need more memory, right? If you have more memory, then all good, because at first you are getting what? You are getting out of memory error, right? And when you see out of memory error, what you will say? Ah, okay, there's a problem in memory. Okay, I'm gonna do what? I'm gonna just increase the memory. You just scale out the cluster, for instance, or scale up the cluster. You just add more memory and all good. Nothing to worry, right? Well, you are actually right. So, if you get out of memory errors, you have a skewed partition and you increase the memory, it's gonna work. Technically, it's gonna work. But then you are not actually solving the root cause. You are actually just trying to, you cover up the problem. So it's more like a painkiller. So increasing memory is more like a painkiller, but not actually dealing with the actual disease. So it's very important here to understand why you have the skew partition, and you need to fix the root cause, not increase the memory. Increasing memory is not a solution, although it will work, but it's not a solution, right? So I hope you understood the concept of skew, and you also understood that you cannot increase the memory to avoid the out of memory errors, right? So then what you can do? So we have actually many solutions in place. So if you see, the first solution is skew hint. Second is AQE, which is adaptive query execution, and third one is salted columns, or the salted columns algorithm. We're gonna talk about each of them one after another. Okay, so very first is skew hint. Skew hint is nothing but a configuration or a property that you can set while performing the join operation. Okay, or not while performing the join operation, but you can set this property on any data frame. So a data frame you expect might be skew, you can set this property. I'm gonna show you in the lab in just a minute, but just for you to know. But this feature skew hint is actually Databricks specific, so you cannot use this feature if you're not using Databricks. So this is very specific to Databricks, so I would not recommend using this one, but it's still for you to know. And now, since I talked about skew hint and that it's just a property that you add on a data frame which you think might be skewed, we can just quickly check in the lab how you can do that, right? So this is my Databricks environment. I hope my cluster is running. Yes, it is running. Let me run first cell. So in this cell, we are not doing nothing, just doing some initialization, getting our Spark context ready. Uh, this is nothing but an imaginary data source. If you see, city1 is skewed, and here also city1 is skewed. So I try to skew this data uh, explicitly just to simulate the problem. And now if you see, let's see the skew data. So let's see what it gives the output. So if you can see here, city one here is actually skewed, right? It has like count of 51. So of course, as expected, because we have created city1 to be skew. So now this city data frame is actually skewed. All good. Now I want to show you first the normal join operation. Okay, so here I'm just disabling everything so we don't get any predefined optimizations from Spark. And here if you see, I'm just doing a normal join, right? Here we are doing nothing but a normal join with a loop operation where we are simulating the right operation but not actually writing anything. Now let's run this. Okay, so this is just a normal join operation which took 8 seconds to complete. We are not actually very much interested in this, but what I want to show to you is the Spark jobs. So here if you see, we have just one job because we have a join operation. And if you remember from my previous video, a job is divided into stages, and stages are actually sequential, right? So we got three stages. Now this one stage is to read transactions. Second stage is to read city, and third stage, which is in this case stage 5, is actually doing the join operation. And you can actually verify this if you don't know what this stage 2. If I click on view, I have this Spark UI where I can see what's happening behind. So if you see here, the records are 59, which is transactions data frame. And if I see this one, it is 5509. So this is transaction, the other one was the city, right? And now if you see here, you can easily see there is an exchange, then there is a short, and then there is a whole stage code gen where it's doing the join, right? So this is the join stage. So we have nothing to actually see very deeply here. This is just a normal join. But if you see this, this is how you set the skew. So transaction.hint skews on city ID. So what I'm saying now to Spark that, hey, this transaction data frame is skewed on city ID. So can you just keep a note of it that this data frame is skewed on city ID, and make sure to perform the operation in a way that it's optimized. So this is how you actually put the hint. You can actually add the hint on n number of data frames, so it's not limited to one, and then you do the normal join. Okay, now let's run it. And now here if I see we have two jobs. Now this is very easy to actually understand because we are doing two operations here. We have two jobs, job 3, job 4. Job 3 is related to skew, job 4 is related to join. Okay, so job 4 actually looks very similar to our previous job that we saw in our normal join, and which also makes sense, right? You read both data frame and then you join. Here also you read both data frames and you join. And what is there in job 3? So job 3 got two stages as well. So in one stage you read, in second stage you reshuffle the data because you wanna optimize this data frame to have the city ID be distributed in a way it is skewed. So this is for the skew operation, this is for the join operation, and it took actually a bit more time, like 12 seconds, but actually does not impact our brainstorming here. We are not comparing the time here, to be honest. We are just trying to understand how you can use these parameters, in the code, and how it might affect the performance. So what I want to show you here is, if we go to the main join stage, and if we try to see all the metrics, so here if you see the partitions, if you see partitions are more or less same, right? We have few big partitions as well, but they are more or less same, as opposed to what you might have seen in the normal job execution. So this was the normal join, right? And in normal join, if I see, I have a lot of big partitions. You see these big partitions, right? And you might see that we don't see a very big difference. It's because the data is not that much. But if you have a lot of data, like big data, and if you compare these two scenarios, you would definitely get the differences. Believe me, I worked with TBs of data, and I am still working with TBs of data in my day-to-day life as a data engineer. So I know it really makes a difference. But that being said, so this is how you can use the skew hint and just do the normal join, and this is how our job stages are working. So this is all about skew hint. Next, we're going to talk about adaptive query execution. So this adaptive query execution, it's a very simple property. Okay, I mean, we don't have to do a lot of coding in order to achieve this. So this is available after Spark 3.0.0, so or 3.1.1. So it's usually available because everyone in the corporate, they are using Spark 3.x anyways. So this is available in Spark, and you just enable a property, and then Spark gonna do a magic by itself and gonna optimize your queries. And how you can add this property, we're gonna just take a look right now. So you see this adaptive.enable true, adaptive.sqjoin.enable true, and advisory partition size in bytes 128 MB. We are not actually very much interested into this configuration, but these two are very important. You just enable both of these configuration, and here you go. You have the adaptive query enabled. And if I run this one, it took comparatively less time, but we are again not talking about time. And if I see the job, oh my god, they are a lot. Mhm. Let's now see one by one what each job is doing. So it has just one stage which is reading the data frame, another stage reading the data frame. What is this? Reading the data frame, applying the skew, reading, and then applying the join. So let's just go one after another. So this stage, if you see, it's 5. It's reading the city. It also reads the city, and then it actually is skew joint rewrite. So it actually do some optimization in backend and rewrite the data. Here 10208, it's transactions. It also has some operations to perform. And then we have the, okay, this is just shuffle read. This is where it's doing the join, right? And if you see here, we have actually almost same partitions. That's crazy, no? Almost same partitions and even less partitions. So you get your job done very fast. You can easily compare this by this matrix. It's very important, very helpful. So that's what I wanted to show you in case of AQE. So this is how you can do the adaptive query enablement, just these properties, and Spark gonna do the magic by itself. Now, third is salted columns or salted column algorithm. This is actually a bit different, and you might have to do some work to achieve this. And I would actually not recommend this in majority of the cases, but since this is also one of the solution that you can use to solve your skew problem, we're gonna of course discuss about this algorithm in this video. But actually AQE should work in almost all the cases. But anyways, we now gonna talk about salted column algorithm. Okay, now what is salted column algorithm? So let's first understand how the normal join operation works, right? So let's say I have a city table and I have a rights table. Okay, now city has city ID, city name, and column 3, column 4. It got 3 values, Mumbai, Delhi, Indore. Then you have corresponding rights in that city from point A to point B. So ride ID, city ID, from to, duration, and fare. So you got these many rides in these many cities. From here to here, you have this much duration and this much fare. Sounds good, right? Now, if you want to join these, you want to join them on city ID, of course, because this is the foreign key. So join key city ID, you join based on city ID, you get the city name here, all good. Now, things to notice here. One thing is, if you see this partition 1, it's good. Partition 2, it's a bit small, and partition 3, it's huge, right? So here it is actually quite easily visible that partition 3 is skewed, right? So yep, so this data is skewed, of course, because you have more data on partition 3 but not the same amount on partition 2 and partition 1. Okay, so this is the skew operation in normal join. Now how you solve this using salting? So what salting says, you salt both the tables and then join them. Okay, sounds easy, no? Just salt. Now let's see. I mean, it's not that tough also, but also not that easy. At first it might be confusing, but after you understand the concept, it's gonna be easy. So how do we salt? So let's salt city. So we have a city table. Now salt factor 2. So this number 2 is actually taken for an example, but you need to select this number very coincidentally because this number affects the amount of data that's gonna be shuffled. Okay, so let's say I have a salt factor 2. So what will happen in the back end, we're gonna have something called salt id. So for each record I am gonna have salt id 1 2, for second record 1 2, for third record 1 2. And now I will redistribute this data to be like this. So I'll create a salt id which is the combination of city id and salt id. So 1 1 1 2, 2 1 2 2, 3 1 3 2, 1 1 2 1, 1 2 2 2, 1 3 and 2 3, right? So it's salt id and city id, and then of course the data. So you might think that this data is actually a bit evolved, right? So it's expanded because we are actually creating another row from the one row. So it's 3 row here, it's 6 row here, but it should be fine. And you should keep this in mind. Okay, yes, in sorting, it's gonna increase the data. Okay, especially it's gonna increase the data for the short or the small data frame. Now we solved the another table which is rights. This is the initial table, salt factor 2 same, you also got 1 2 1 2 1 2. But in this case if you see, each record is not 1 2, but so if you see here, each record is not actually mapped to 1 2, but the city IDs are mapped to 1 2 1 2 1 2 1 2. And now if I create salt ID similarly like I created here, it's gonna be something like this: 1 1 2 1 1 1 2 2, like this. And now if I join both the tables, so this is city salted, right, salted. Now the join key is salt id, of course, because you are creating salt id in both the tables. So now you need to join on salt id. And now if you see, it looks different, right? So we have a quite small partitions. So it's a bit more evenly distributed as compared to the previous distribution. I'll just show you comparison side by side. So this is before salting, we have a big partition. This is after salting. Our this big partition is actually divided into two small partitions, if you see, or even the smaller ones. So this is how you actually redistribute your data in a more wiser way, so that Spark can do its work in more optimal way, you know. But one thing to note, you might be thinking that some of the partitions are actually became even more smaller, and that's true. So there might be scenarios where some of your small partitions can become even more smaller, and this is one of the downside of using the salting. Okay, so you should keep in mind that your small data frame gonna be a bit larger, and on the other side your small partitions might go more smaller. So uh, this is also something to keep a note when you decide to choose salting as your optimization technique or a solution to avoid skew. Okay, but here if you see, the main reason is to have your all task completed without failing, without getting out of memory errors, right? So you have a small partitions, even you have a smaller partitions, there is a guarantee that the task will be succeeded, right? You will not get the out of memory errors, you know. So the main point here to note is, we are here talking about solving the making sure that each task actually completes and not hang or give out of memory errors. So this is how the salting works, and now let's see it in practical. So again we false the AQE. Now here I am using 7. The 7 is randomly taken because we have a dummy data, we don't care much. Okay, but this number is very important in terms of skew factor, so please make sure that you take this number very precisely. Now you create a salted city id with city id and salt. Similarly you create again city id and salt for transaction, and you join on salted city id. And I am gonna just run it again. 6 seconds. Okay, we are not talking about seconds again. And the jobs are huge. We are not going to talk about all the jobs because I think by now you already get an idea like what stage do, what job do. We're gonna go to last stage where it's actually joining. And if you see, we still got some good partitions and some very small partitions like these, very small partitions, right? So this is a downside, but I think you got the idea. But in this case, actually all the tasks would be completed anyways, right? So the goal here is to make sure that the task actually succeeds and do not hang in the middle. So that's the main purpose of the sorting. So that's all. I hope you understood what the skew problem is and how you can solve it. We primarily got three ways to solve it, and I recommend AQE. It's easy, it's Spark way optimizing, and you don't have to deal with a lot of coding by yourself. So that's all in the skew chapter or the skew video. I hope you understand the concept, or if you have any questions, please write in the comments and I would be very happy to answer them. Or if you know any other way to solve this problem, please do let me know in the comments because I am very open to learn new things and new ways to do this stuff. So please do let me know. And we're gonna meet you in the another video on another problem in Spark. Until then, have a good day. Bye bye.